Hello class, this is a video tutorial on integration by substitution part 2. In this video we'll be looking at evaluating definite integrals using substitution. So when integrating by substitution, the x values can actually be converted to the equivalent u value. I'll demonstrate to you very quickly in this examples. So once here, we do as we normally would, so let u equal x cubed plus 1 du on dx equals 2x squared. From here we also will get 1 on 2x squared du equals dx. Now from here we could just continue as we normally would. When we integrate this, we get u to the power of half times x squared times dx, which we substitute as 1 over 2x squared du. Hope you can see we can cancel these, leaving us with that half on the outside like so. So half to the power half times the integral of u to the power of half du. Notice how I've left out these values because these values are the values in x. All right, so we can't really show the values here. So if we were to continue this as we normally have, we get half times u to the power of 3 on 2. This would cancel out these. We get 1/3 u to the power of 3 on 2. Then from here, we resubstitute our values back in. So we get 1/3 x cubed plus 1 from 0 to 2. Notice how only now I resubstitute my values in. But we could actually, right from the beginning, change the values of 0 and 1 using this expression here. So for example, when we let x equals 0, u is equal to 0 cubed plus 1 equals 1. So instead of from x 0 to 2, 0 will actually become u equals 1. And when x equals 2, u equals 2 cubed plus 1, which is 9. So instead of x equaling 2, u equals 9. So from 1 to 9 instead. And it's actually this that we can substitute without having to resubstitute the expression back in. So our question becomes a little bit simpler, where we substitute 9 into here. So substituting 9 to the power of 3 on 2, we get 27. Take away, well, substituting 1 to the power of anything is just 1. So it's going to become 26 times 1/3. We get 26 on 3 is our definite integral value of this integration. You could, if you'd like, resubstitute back in the expression for x and use these to integrate the definite integral, and you'll see that you'll get the same definite integral value. Okay, so you can pause the video and give this next question a go yourself. So here we go. So we let u equal cosine of x, du on dx equals negative sine of x. So negative 1 on sine x du equals dx. And then when we're going to substitute u for cosine of 0, cosine of 0, u equals 1, and u equals cosine of pi on 6. That becomes pi on 6 is going to be square root 3 on 2. So it's these two u values that we're going to use. So substituting all these values that we need, our integral is now actually going to be from 1 to root 3 on 2 of cos of x is now going to be u, that's u to the power of 4, times sine x times dx, which is now going to be negative 1 on sine x du. Hope you can see that these two will cancel. This leaves us with negative of the integral from negative 1 to root 3 on 2 u to the power of 4 of du. Integrating this, we get negative 1/5 u to the power of 5 root 3 on 2. Factoring out 1/5 to make it a little bit easier. Now substituting root 3 on 2 into here. Root 3 on 2 to the power of 5. We get 9 root 3 on 32 minus, substituting 1, we get 1/5. So minusing 1/5 from this answer times negative 1. On my calculator, it simplifies it for me. I get 1/5 minus 9 root 3 on 32. Okay, well, I hope that gave you an insight into how we can simplify evaluating different integrals with substitution by changing the x boundaries into the equivalent u values as shown here. So I hope to see you in the next video, and best of luck.